What up? Today is Monday, December the 12th, and we are finally solving today's challenge. We are not anymore officially behind schedule. Okay, we are maybe slightly behind schedule, or there's a risk of us being, but at least we are catching up with quite good speed. And as previously, we are solving this in the programming language NIM. We're trying to learn NIM while we're solving these challenges. Big recommendations. If you wanna learn a new programming language, do the Advent of Code challenges. You will definitely sort of like know how to work around in a new programming language if you solve these things. Okay, but to today's problem. So we're doing hill climbing, and we're giving a height map of the area that we're in. And we start at capital S and we want to end at capital E. And all the other letters are lowercase letters from A to Z. And what these letters signify is the height of that sort of like that block where we're at. So for example, A being the lowest and Z being the highest. And our sort of like task is to find the shortest way up from S to E. So yeah, if you've ever done something like this, you might be thinking like Dijkstra's shortest path algorithm or BFS. We're actually going to use BFS, I think, to solve this. And that's also reason I think this is not going to be like a super challenging. I think we're going to be able to do like quite a pure implementation of BFS to solve this thing. So yeah, what are the rules? Yeah, so as said, we start at S, and then from S, where can we go? We can go to A, and we can go to A. We can't go diagonally, okay? And then, for example, from this A, we can go to B. That's one up. So we can't jump higher. So, but we can go to B as well, and then we can of course go to the starting position. But then this B here, we can go back to our A. We can go to C because C is one higher, but we cannot go to that P because P is way, way, way higher. We're only allowed to increment by one at a time. We can go back more if we want though. So these are the rules. And yeah, I think this is pretty straightforward. Let's get coding. So I've imported the matrix library that we've used previously. So this is what we've been building on, and it's yeah, it makes sense to use this because we're dealing with, again, with the two-dimensional structure. And m.data equals collect. So collect comes from the sugar module, and then we can say for item in file if and we have to cast to a string if item does not equal, because now it takes all the new line characters. We have to check for that. If item does not equal, then item. So now we're collecting all these, and now we can echo m, and bam, we have read in the input. So this is kind of like list comprehension in Python, that we can sort of like do some operation on like an iterable, and then we just like collect whatever that returns. Maybe that's sort of like the idea here. But yeah, so now a lot easier input parsing than in the monkeys example, definitely. And the next thing we need is a way to, again, transfer the individual letter to a height. So this is actually something we've done before. Just like echo elevation as well, just to check that it's right. And it is correct. All right, moving right along. So now we're actually going to program the BFS algorithm. Yes, and it's going to return an integer. And what are we going to take in? We're going to take in a starting position, which is a tuple of int and int. So we're going to have a var visited. So because we're going to be keeping track on which places we have already been to, and we want to like double check those, like a core part of the BFS algorithm. So it's going to be a to hash set, and then we're going to pass in the starting position. I think it should be like this. Yeah, exactly. So in an array, and then we're going to do like var.q. So this is going to be our double-ended q, and it's going to also be an array, and you can do like two dec, and in here we're going to put in like our I think we should actually have them in like that. So it's going to be start 0 and start 1, and then also the distance, because we want to keep track of the distance. So like, what is the shortest distance from our position to the end position where we're gonna go. So I think these are initialized correctly. So let's move on. Okay, and then comes the logic. So while we have anything in our queue, so while q dot len is more than 0, so what we then do is we're gonna grab our ij and our distance. So we're gonna take like q dot pop first. Yeah, exactly. Pop first. Yeah, exactly. These are. Yeah, exactly. Yeah, we wanna pop the first item from the list, and we're getting an error. Oh yeah, because we have to put like var, of course. And then yeah, let's take that again. So then we do while we have anything in the queue. So while q dot len is more than 0, then we're gonna pop the first item in the queue. So we can say var, and now ij, and I'm gonna call this just like this. So x, y, and distance. But yeah, it's good with refreshment. So we can take like q, and we can do pop first. So that takes like the first, like in yeah, the first. I think this is the same as what's like left pop, something like that in Python. Okay, and then we can do like a quick check. So if m.i j is equal to the end, so then just result equals d. Result like that. So if indeed the place we're inspecting, then we just return the distance, and you're gonna see like we're gonna be tallying up the distance. So this is the last place where we're gonna end up, and this is gonna be triggering when we finally reach our goal. Okay, so this won't be triggering like for any time soon. To the actual logic, and we're gonna have, let's call this ni and nj in, and now let's just do it like this. So in I plus 1 j, in I minus 1 j, and then in, now we're gonna have like I and j plus 1, and then I and j minus 1. I think you're seeing what I'm getting at here. So what we're doing is like this here, this is an array consisting of these tuples, and then we are at position ij, and then we're looking like so this will be to right, left, down, and up, for example. So that's what we're gonna do. So like for each of this square, we're gonna look at in all 4 directions, and then if we're in the corners or on the edges, we have to have some bound checking. So now that we have this long, beautiful Boolean expression, so let's quickly check that. What are we doing here? So yeah, if we're here, we also want to do that, and we also want to do visited, and it's called include, and we want to put there ni and j. It should be like that. So this is in case like we're standing at a place, and the next box that we're currently inspecting is equal to e, and basically that the sort of like elevation of, yeah, sort of basically checking that from C to there is like a possible move. Then we're gonna add that to like the queue, and then here we're doing some additional checks. So if the next block that we're inspecting is not the end, and this is a block that we haven't inspected yet, and that this block satisfy the condition that we can only step up with 1, so current minus outer has to be less or equal to 1, then we add this also to the list that we want to inspect, and we also add this to the visited set to make sure that we don't visit this doubly. Okay, and I think this is actually it. I don't think there are any more details to this. So let's see what happens when we start running this stuff. So after some intense debugging of wrong indices and syntax errors in some of these statements, or just like they weren't strictly syntax errors, but like silent bugs, things that were wrong. So now I'm getting the 31 this returns, and that's what we expect from this one. So you can reach the goal in 31 steps. Okay, so now you all know what the next thing is. So I already have my input here, and it's, as you can see, quite a nice animal. So let's just replace that with the input, and let's see what happens. Am I echoing stuff here? Just okay. So long story short, I had several subtle bugs in the code, and let's start with the first one. The first one was how I read in the file. I used the sugar module and the collect thing, and that did not work as I anticipated. So it's not equivalent of what we're doing here with the basic for loop, especially when we're putting these into the matrix. And then also I had messed up some of like the matrix indexing and that sort of stuff. So like definitely makes you appreciate libraries that, for example, NumPy, PyTorch, all these that have like a solid tensor matrix library to work with instead of building your own. But all right, so now I get the correct answer with that one, and I have a lot of these things here. And also when I input the actual the input file, input.txt, we actually do get some answer that is other than 0. And of course, in good spirit, I haven't still checked this, so this could be totally wrong. But now let's see, and yes, perfect, it worked. So yeah, this was actually quite cumbersome to debug, and yeah, mainly because of a lot of things that I've done, that I did wrongly before. So finally, we're able to move on to part 2. Okay, so part B. So now we need to find the shortest path from any elevation at A to the square E. So basically what I'm thinking is now we should sort of like go through the whole matrix, and then we should check if that sort of place is marked by an A, then that also marks a starting point, and then we start from there traversing up. So for example, in this case, there are 6 choices of starting point, 5 that are marked with A, plus the initial S. And then from all of these, we calculate, first of all, whether it's even possible to get up. If it's possible to get up, then we like calculate the length, and then we just store all the lengths in some temporary sequence, and then we check which one is the shortest. I think that's the thing. Yeah, which is the fewest steps required, starting from any square with elevation A. So I think this requires quite minimal change to our code. Let's do this. So yeah, the first thing I'm gonna do here is something like this. So we should check that if that's that, then we should change it to an A, because we now basically that means the same thing. So there we go. So we have, according to this one, there are 5 plus 1, so 1, 2, 3, 4, 5, 6 possible ways, and then the shortest would be 29, which is what we get there. So let's just still like write something to find the minimum. Input.txt, and we wait a while and we get 416, a very plausible answer, and that is right. Boom! All right, so we haven't been so successful with this, but once we got going, it worked. Really nice. So, and now we go to learnings. So I think now we're reaching a certain level in these assignments that we are sort of noticing that NIM is a very young language, and we don't have all these fancy how to say, like built-in libraries that are sort of standard. Like for example, let's compare to Python. So Python, you have like pandas, numpy, all these really convenient things that have been with you for a long time. You basically, when you start learning Python, you basically start learning them with sort of like pandas and numpy already like included in a way. You sort of like, you don't start learning Python without learning about numpy. That's, I think, like super uncommon nowadays. And with NIM, there just isn't like yet these similar equivalents. Yeah, for sure we have different tensor array libraries, but it's a bit more scattered. They are not as tested. It would actually be fun, like in a future video, if we're gonna do more like matrix stuff, maybe use one of these matrix libraries instead of like doing our own stuff, because as we saw, this is a good way to shoot yourself in the foot. But yeah. Otherwise, so far we used hash sets and double-ended queues for the first times. Those are like pretty much the same as in any other language, I think, like very similar to Python. It's called pop first and not pop left, and like, yeah, but it's the same thing anyways. So yeah, all right, let's wrap it up and go on to the next one.